Hello everyone, this is Dr. Fan. Today let's discuss a very interesting type of question, projectile motion on a ramp. This is a pretty hard question, and we actually need a different method to solve this type of question. This question is hard, and if you are able to solve this question, you should be very good at physics, and you should be ready for physics competition. Alright, let's look at this question in detail. This is the setup of the question. A ball is thrown upward from a very long ramp with an initial velocity of v0, which is fixed. The incline angle of the ramp is theta, which is also fixed. So they ask, under what angle, this alpha angle between the velocity and the ramp, under what angle the ball can reach the furthest along the ramp. So they are asking the maximum range along the ramp. You can pause here and think about your method to solve this question. Alright, usually when we solve this type of question, we construct our coordinate system along the x direction and y direction. You can try this method, but for this specific question, if you use horizontal and vertical axis, it's very hard to solve this question. Instead, today I'm going to discuss a new method, which is reconstructing the coordinate system. So for this question, we're actually going to construct my x-axis along the ramp direction and my y direction perpendicular to the ramp. Using this coordinate system, I can solve this question easily. Alright, let's see what happens if we construct my x along the ramp direction and y perpendicular to the ramp direction. If I construct my x-axis along the ramp direction, then my initial velocity along the x direction will become v0 times cosine alpha. And then my initial y velocity equals to v0 times sine alpha. This is great, but the acceleration becomes a little bit tricky because we know when the ball is in the air, the only acceleration is g. But in this case, acceleration g is going downward, but my axis is along the x and y direction. Because of that, so I need to decompose my gravitational acceleration. So this is my acceleration along the x direction. This is my acceleration along the y direction. Because I know this angle right here is theta. So my acceleration along x direction is g times sine theta. But because it's going to the negative direction, so it should be minus g sine theta. Similarly, my acceleration along y direction should be g times cosine theta, but it's also going along the negative direction, so it should be minus g cosine theta. You see, under this new coordinate system, my motion along the x direction and the y direction are both constant acceleration, and this is my new acceleration. Then I can use my Big Five equation. I know the range along the ramp is basically my displacement along x direction, which equals to v0x times t plus half a t squared. And this acceleration should be acceleration along x direction. And I know my v0x and I know my acceleration, so I can substitute this in. This equals to v0 times cosine alpha times t plus half times minus g sine theta times t squared. So this question basically asks how I can maximum my range. In other words, how I can make my x displacement the largest. I know everything except the time. So how do I find my time? That would require knowledge along the y direction. We know along the y direction, the motion is also constant acceleration. So this velocity here, v0y, is actually decreasing. and this is the deceleration rate. We know at some point this vertical velocity Vy would decrease to 0. Then this Vy is gonna increase but along the negative direction. So Vy should increase, right? Because this acceleration is going to the negative direction. So how do we find the time after launching to the moment when the ball hit the ramp? Which is very straightforward because now our coordinate system is perpendicular to the ramp direction and along the ramp direction. After the ball is being launched to the point the ball hit the ramp, the vertical or the y displacement is 0. Then that means this velocity here, Vy final, this Vy final should equals to Vy initial, but with a minus sign. You can consider my ball is leaving away from the ramp, then coming back to the ramp, and this motion is symmetrical. So because we know the final vertical velocity, we know the initial vertical velocity, we can find out the time. So the time can be found out by Vy final minus Vy initial, then divided by the acceleration. So this equation will become minus V0 sine alpha minus V0 sine alpha divided by minus g cosine theta. So then the total time here equals to 2V0 sine alpha divided by g times cosine theta. This is the total time when the ball hit the ramp. So now if we substitute this time into this displacement equation, we should be able to find out the displacement along the ramp direction. I have already done that, and this is the displacement, which is 2V0 squared divided by g cosine theta squared times sine alpha times bracket cosine alpha cosine theta minus sine alpha sine theta. This equation looks pretty busy, but when we look at this reminds us of one of the trig identities, right? So we can rewrite this equation as 2V0 squared divided by g cosine theta squared times sine alpha. Then this whole thing becomes cosine alpha plus theta. So now this is my displacement along the ramp, and I want to maximize this displacement, right? So when we look at this equation, V0 is a constant, theta is a constant. The only thing that we can change is the launching angle. But now the problem is that this alpha here is in two terms. If we can have this alpha just in one term, we should be able to find the maximum displacement very easily. So when we look at these two terms, it actually reminds us of one of the trig identity. And let's use that trig identity. So for the first part, 2V0 squared divided by g cosine theta squared, which doesn't change. But this term here, we can use the trig identity, which is this whole thing here equals to sine alpha plus theta, then plus sine alpha minus alpha plus theta, and then divided by 2. And this is one of the trig identities. Why are we doing this? Because after this step, my equation will become 2V0 squared divided by g cosine theta squared, then times sine 2 alpha plus theta minus sine theta divided by 2. So you can see that now this new equation only has this term changing. All the other guys are a constant. So if we can maximize this term, then we will maximize my displacement. So how can I make sure sine 2 alpha plus theta is the largest? We just let 2 alpha plus theta equals to 90 degrees. Then I'm gonna maximize this term. Then my displacement will be the largest. And under this situation, my alpha basically equals to 90 minus theta divided by 2. So this will be the launching angle that make my displacement the largest. And under this angle, my maximum displacement actually equals to V0 squared divided by G cosine theta squared times 1 minus sine theta. That's it. And we can actually evaluate to see if this equation makes sense or not. If we let theta equals to 0 degree, so instead of a ramp, it's just throw a ball from a horizontal. In that case, the angle equals to 90 minus 0 divided by 2, which is 45 degree. And we know under this angle, my range will be the largest if I threw the ball from horizontal. And my maximum displacement, my maximum range equals to V0 squared divided by G. So this equation here is correct under theta is 0. What about theta is 90 degree? In that case, alpha is 0 degree. And in that case, my maximum displacement along the ramp is 0. Which also makes sense because if theta becomes 90 degree, that means your ramp is basically going vertical, so the ball will never hit the ramp. So in today's discussion, we didn't use horizontal and vertical as our coordinate system. It's very hard to find the solution for this question if you use horizontal and vertical as your coordinate system. Instead, today we used a new coordinate system, which is along the ramp direction and perpendicular to the ramp direction. And then our motion along the x and the y becomes two constant acceleration along the ramp and perpendicular to the ramp direction. If you see similar questions, try this new method. In many cases, it's gonna make the question much easier. Hope that today's discussion make you understand projectile motion better. If you have any questions, feel free to comment. Thank you. I will see you next time.